So now I'm going to I have selected all the operations, and I'm now ready to run the G code. I'm now ready to generate the G code to create the program. So I go up here in my software. This is what I do, but different softwares might have a different procedure. But it's kind of going to the post processor, and this is what generates the G code. Okay, it wants to save it in here. I'm gonna say, let me call it up. Okay, this already exists. Okay, so it already made the code, but it's gonna put it somewhere. It put it like in a different folder. Okay, this is where it saved it. Let me open it up. Okay, there's your program, but it saved the program onto like an NC file on my computer. But I'm going to now take this program and save it into my floppy disk, because I'll take the floppy disk into there. I'm going to physically carry the floppy disk and put that in the machine. So I'm just going to save this guy into my floppy, and the Geneva will, and I'll save the program in there. Now let me open it up in the floppy to see it. Okay, there goes my program. Okay, now there, this is my program. This is what I'm going to take. I'm going to take to the machine. You can see tool number 2, tool number 4, tool number 15, tool 16, tool 17, and that's my program. That's my first tool is tool number 2. M6 is the tool change command. G54. That's my part offset. Okay, it looks good, and you can see how long this program is. And the last line is always M30, so it's gonna end G91, G28, Z0, G28, X0, Y0. I don't really have an A axis, but this post processor brings the A axis in just to finalize everything. Now you're gonna notice that in some machines don't like some machines, if they're a 3-axis machine and the post processor brings in the A axis, when you go to the machine, you might not see your program. The program might not open. So you have to go in and edit and remove like any reference to the A axis and stuff like that, because some machines don't like that. So, but in case you take your program to the machine and it doesn't open, sometimes you have to come back and do such edits. So you can go to the notepad and just come and change whatever you don't like, in the program. Like I say, this post processor will reference the A axis, but the mill that I have doesn't really care about that. It opens it up. So it's time to go to the machine. Okay, I'm going to go ahead and call up the program that we just saved. I'm going to go into File, Load G Code. Okay, so pretty much this is what you see. And the graphics should just look like whatever, like how your how the program looks in the software. It should look the same way. You can see the entire program also comes over here, and now
Now we're ready to set up the fixture. We're ready to set up the workpiece on the fixture and touch off the tools, and then we're ready to rock and roll. Now the table is clean and ready to set up the workpiece. So this is my quarter-inch workpiece, and this how the aluminum is about a half an inch. So what I'm going to do is I'm going to set the half-inch thickness aluminum down, the half-inch thick aluminum down, and this workpiece is going to go on top of it. And first I'm going to use this some dowel pins just for location, to help set the location. I used these 2 dowel pins on this side. Look at that hole, it's kind of dirty. Set the dowel pin. So I'm going to bank it this way and put another 2 over here on this side. This is just to help locate the fixture nicely. Okay, this is good. So I'm going to bank it over here and on those 2. So now I have my 2 plates. So the thinking here is, this is my workpiece. So after I machine the first passes, I'm going to use screws to hold down the workpiece. I'm going to screw it onto the bottom piece so that my parts don't fly off as I machine them. So that's the logic. You also take precaution to make sure that your clamps are out of the way. You don't want your clamps to be on the way of the toolpath, because the machine will move according to the program. So it's your job to make sure that the tool will always clear the clamps. The fixation has to be very rigid. It has to hold down the workpiece very firmly. The workpiece cannot even vibrate. It cannot even move even a little bit. Now, here are all the tools that I'm going to be using. This is my reference tool. My reference tool number 1. This is my edge finder. But what we notice is all these tools are going to go into the machine. Okay, let's see. All the tools fit into the machine in a similar manner. So I go like this and place it in. And this height, the height from over here, the height from this spacer to the bottom of the tool is what's critical. So all my tools fit the same way. Put the tool in, release the tool. My edge finder fits the same way. Press, blow it in, release it. All my cutting tools fit the same way. This is the drill. That's a 470 end mill. This is the 187 end mill. And also, like I said, this is a 2-fluter. I can use a 2-flute or a 3-flute because I'm cutting aluminum. This is a 3-flute end mill also. But now, to locate the X and Y, the X and Y 0, I'm going to use this edge finder. I'm going to touch off here and find the middle of these two. That's going to give me my X0, Y0. But to find where my workpiece is on the Z axis, I'm going to use tool number 1. I'll touch it off over here, and I'll record this height of it in my tool offset table, and then I'm going to just measure the rest of the tools. I'm going to take the same distance for the rest of the tools and enter those values into my tool offset table, and that way all the tools are going to know where the part is. So we're going to go ahead and do that. So I'll measure this height for all my tools and record it down. Then I'm going to take those measurements and add them to the tool table. So 0. So my tool number 1, I'm going to measure from, if it sits here, that's the floor, that's the bottom. Then I'm going to measure its height to here using a height gauge. Okay, the height is 2.845. That's for tool number 1. Okay, I'll put it aside. I'll take the next tool, which is the center drill. I'll do the same thing. I'll measure the distance from the bottom. It's going to be from the bottom to the tip over here, and I'm going to record that. It's going to be 3.172. Then I'll do it for the next tool, which is the 159 drill. I'll record again from the floor to up here. I find it to be, the distance is 4.734. So I'll do that for the rest of the tools and put all the offsets down. Then I'm going to take these numbers and load them onto my tool offset table, and that way the machine will know how far each tool is from the workpiece. Now I'm going to go into my tool offset. The tool offset table, it's going to be under config. It says tool tables. Now this is my tool table. It's kind of hard to see it, but let's open up my tool table, see if I can zoom in. For tool number 1, it says 2.853, and yes, 2.853. I just measure it. This is the previous one I'd measured like a long time ago. So I'm just going to go back and say, and retype in there to correct it, because what I just measured say 2.845. So I'm going to go in and put 2.845 and apply it. Then I'm going to go to tool number 2. Tool number 2, I measured it. What I just measured said 3.172, and I'd previously measured it. This is before to 3.178. So I'm just gonna change it to what I currently measured, which is 3.172. 3.172. and apply it. And then my tool number 4 offset remains the same with what I measured and what is in here, which says 4.10. My tool number 15. Tool number 15, I measured to 3.503. I'll keep it the same. Tool number 16 stays the same, 2.819. And tool number 17 also 3.110. So this is where I'll be putting my height offsets. So now the machine will use these values here to locate where the workpiece is. So that part is done. Now we're going to go ahead and touch off the X0, Y0, and the Z0. Then we're ready to machine. So come back to the screen here. So to find X0, Y0, we load our edge finder and start the spindle, slow speed. So now we're gonna touch off the X first. Okay, let the edge finder go. We're gonna go in slower increments until it touches. Okay, it touched over there. Okay. My edge finder has a diameter of 0.200 or 200 thousandths. I'm gonna come back and move my tool an extra 0.100 and then record the X0 position. To find my Y, I'll find the center. Okay, move Y to the center. I'll move Y to the center of this number. That's gonna be the center of our piece. It's gonna be 2.10. If I move on to 2.10, that's gonna be the center of our piece. 2.1. Okay, let's slow it down now. Now that's going to be Y0. So now we know X0, Y0. Now we need to find Z0. We need to find Z0 by touching off tool 1 to the top of the part, and then we're ready to machine. I'll bring it as close as possible first, then I'll slow it down, and I'll use a paper. Once the paper stops moving, now I'm moving it 0.001 at a time. Once the paper stops moving, I know it's about 0.001 off of the face of the part. Then I can record that number, and now we know where the Z0 is. Okay, so it's touched the paper. I'm going to record. I'm going to record that as Z0. Remove the paper and move it another 0.1 down. Okay, now that is my Z0 now. Now we're ready to machine. So I'm going to load up tool number 1. And then at the same time, I'm gonna put the offset up maybe 4 feet up on top, and then I'm gonna run tool number 1 just on the air. I'm gonna act like the Z offset is up on top of the part, just to cut the air, just to prove out my my program. I'm gonna load tool number 1. Now I'm gonna act like I'm actually cutting the part, but it's just going to cut it up in the air. So there we have tool number 1, and then I'm going to put the feed very low, and now I'm just watching to make sure that everything is working right. Start the spindle. Set the program. Okay, I have feed rate is very low. So the first time you're running the program, you gotta be very cautious, listen to everything, and watch. Just make sure the machine is following, is going according to the program. Okay, cycle start. Go. Tool change. Cycle started. Okay, it's moving to the location, the first drill hole location. Then it's dropping down to go drill the first hole. But I'm running at a very conservative rate. Okay, there it's cutting at 4 inches on top, which is what I wanted. So now I can increase the feed rate. It's doing the second hole. Third hole. So it's running, looks like it's running good. There's no surprises. Done all the holes. It's going to wrap it back to the tool change position, ready for tool number 2. Normally, when your first tool runs nicely, then you know your program is good. Okay, I'll run the second tool just for the hell of it. It's still running up in the air though. So. Change. Notice the peg drill. This is the peg drill cycle. It's going down, then it comes back up, it ramps back up. Now this is the peg drill cycle, but everything is up in the air just to prove that the program works. It's running good, so I can confidently now go back and put the offset down and run the program confidently. Say now, okay, we're ready to go and run the program in, and I can start ramping up the feed rates and stuff. I know it's running good.